Hi, I'm Oluwakemi. I'm excited to have you here again. This is JAMB Physics 2018, question 1, which goes thus. A galvanometer of internal resistance 50 ohms has a full-scale deflection for a current of 5 milliampere. What is the resistance required to convert it to a voltmeter with full-scale deflection of 10 volt? To measure the maximum voltage by the voltmeter, the high resistance R is connected in series, and so the voltmeter is equal to the current deflected in the galvanometer, okay, multiplied by the addition of the high resistance plus the internal resistance R. The high resistance capital R, the small resistance small r, okay? And in this case, we have V equals to 10 volt as given in the question, okay? Also, we have the capital R, which is the resistance, okay? We are looking, that is exactly what we're looking for. We also have the I, the current deflected in the galvanometer. We have the 5 milliampere. For 1000 milliampere is equal to 1 ampere, okay? Which means that 5 milliampere will be equal to 1000 divided by 5, and that will give us 0.005 ampere. Alright? We're also given the resistance of the galvanometer, small r, which is equal to 50 ohms. Okay, good. So now we're going to input these values in the given equation. So for volt we have 10 equals the I as given 0.005 brackets R plus 50 ohms. Alright. Next, we need to divide both sides of the equation by 0.005 in order to eliminate it from the left hand side. Okay. So this cancel this out. 10 divided by 0.005 will give us 2000 equals R plus 50. So if we subtract 50 from both sides of the equation, we have R equals 2000 minus 50, and that will give us 1950 ohms. Okay, and that goes with the answer option B. So answer option B is the correct answer. Thank you for watching. See you in the next video. This is question 2, JAMB Physics 2018, which goes thus. If x times 10 raised to the power minus 2 joule of work is required to move 100 microcoulomb of charge from a point X to a point Y in an electrical circuit, the potential difference between X and Y is, the potential difference is the work done per unit charge, which is V equals W over Q. V here is the potential difference in volt, while W is the work done or energy transferred in joules, while the Q is the charge in coulombs C. Okay, so let us try to input the values as given in the question. V, which is the potential difference in volt, is exactly what we're looking for. That is unknown, okay? While W, the work done as given in the question, is this. So we have 8 times 10 raised to the power minus 2, okay, to be divided by the column. Remember that the column we're given is 100 microcoulomb, okay? And 1 millionth microcoulomb is equal to 1 coulomb. Therefore, 100 microcoulomb will be equal to 1 millionth of this divided by 100, and that will give us 10 raised to power minus 4. That is to divide this by 1 million. Okay, good. So we have Q as 10 raised to power minus 4. So let us simplify further. So V equals 8 times 10 raised to power minus 2. In indices, if we bring this 10 raised to power minus 4 up, we have 10 raised to power 4. Okay, so we simplify further. So we have V equals 8 times this, and indices would be 10 raised to power minus 2 plus 4, and this will give us the final answer. 8 times 10 raised to power minus 2 plus 4 will give us 2. So the final answer, the potential difference between X and Y, is equal to 8 times 10 raised to power 2 volts. And the answer option C seems to be the right answer. So this is the correct answer. Thank you for watching. See you in the next video. Question 3, JAMB Physics 2018, which goes thus. In a meter bridge experiment, 2 resistors, 2 ohms and 3 ohms occupy the left and right gaps respectively. Find the balance point from the left side of the bridge. A meter bridge is used in finding the unknown resistance of a conductor as that of in a Wheatstone bridge. Okay, and the Wheatstone principle states that the resistance on the left, the ratio of the resistance of the left to the ratio of the resistance to the right is equal to the length to the left over the meter rule. The meter rule is 100 minus the length to the left. Okay, good. So now we're going to substitute the values. The ohms, that is the resistance to the left, we're given is 2 ohms. So we have 2 over the resistance to the left, that is 3, okay, equals L bracket 100 minus L. Okay, so now we cross multiply. So we have 3L equals 2 times 100 minus L. We have to open the bracket now. So we have we have 3L equals 2 times 100. We have 200. Then minus 2L. So now if we collect the like terms, on the right hand side we bring 2L. So we have 3L plus 2L equals 200. Okay, so 3L plus 2L will give us 5L equals 200. So now we have to go ahead to divide both sides by 5. So these cancel this out. Okay, then 5 and 200 will give us 40. Okay, so the length to the left is 40 centimeter. So the answer option B is the right answer. Thank you for watching. See you in the next video. This is question 4, JAMB Physics 2018, which goes thus. 250 microfarad parallel plate capacitors are connected in series. The combined capacitor is then connected across a 10-volt battery. The charge on each plate of the capacitor is, remember that the capacitors are connected in series, and so to find the total capacitance, which is 1 over C, equal to 1 over the first capacitor plus 1 over the second capacitor, and this is going to give us 1 over C equals 1 over 50. Remember, we're given as 50 microfarads. Okay, so now we're going to have, since we have in the fractions we have the same denominator, we're just going to add the numerators together. So we have 1 plus 1, which will give us 2. So we can go ahead to divide. So we have 1 over 25, and then simplify further. We have C, that is, if we cross multiply, we have C equals 25. And remember, take note that we've been doing this in the microfarad units, which we need to convert to farads. And for the microfarad, we're talking of 1 millionth microfarad will give us 1 farad. Okay, and that means that we're going to divide 25 microfarad by 1 million, okay? So we have 25 times 10 raised to power minus 6, okay? So minus 6 farad. So this is the capacitance. So now we need to calculate the charge stored in a capacitor, which is equal to, the charge is Q, which is equal to the capacitance C times the volt applied to it. And with this, we already have the capacitance, which is this 25 times 10 raised to the power minus 6, to multiply the volt applied, which is 100. So we have 100. Okay, so if we simplify further, we have 25 times 10 raised to the power minus 6. Then this is 10 raised to the power 2. So in indices we now have plus 4, and this is going to give us 2, that's 25 times 10 raised to the power minus 4. And if we leave this in indices form, we're going to have 2.5 times 10 raised to the power minus 3 column. Okay, so if we check the answer options, the right answer option is B. Good. Thank you for watching. See you in the next video. This is question 5, JAMB Physics 2018, which goes thus. What is the total electrical energy consumed by using an electric cooker rated 1000 watts for 5 hours? The electrical energy equation or formula is equal to E equals the power, which is measured in watts, times the time T, which is measured in seconds. Okay, so now if we go back to the question, we will see that the power given, which is in watt, is 1000, okay, times the time given, which is in hours, and that is 5. So we need to convert that to seconds. So we have 5 times 60 times 60. Okay, good. So now we can quickly use our calculator to multiply this. So we have 1000 times 5 times 60 times 60, and that will give us 18 million. Okay, so we have 18 million, and if we're to leave that in indices form, we'll have 1.8 times 10 raised to the power what? Okay, let us count. 1, 2, 3, 4, 5, 6, 7. 10 raised to the power 7 joules. Okay, good. So now let us check the answer option. Answer option C is the right answer. Good. Thank you for watching. See you in the next video. This is question 6, JAMB Physics 2018, which goes thus. the power dissipated in an AC circuit with an RMS current of 5 amps, RMS voltage of 10 volts, and a phase angle of 60 degrees is the power represented with the letter P, is equal to V times current. V is voltage, I is current, cos theta. Okay, the V and I are sinusoidal RMS values, okay, while the theta is the phase angle between the voltage and the current. Alright, so now let us solve for the power. Alright, so we're going to input the value. The volt as given is 10 volts, and the volt as given in the question is 10 volts times the current, which is given as 5 amps, then times the cos theta, which is given as 60 degrees. Okay, good. So we simplify further. We have 10 times 5, that's 50. Then cos 60 is 1 over 2. And this is going to give us final answer. 2 goes in here, 1, 2 in there is 25. So power is 25 watt. Okay, so if we check the answer options, answer option A is the right answer. Thank you for watching. See you in the next video. Question 7, JAMB Physics 2018, and the question goes thus. The voltage of the domestic electric supply is represented by the equation. This given equation determine the frequency of the AC supply if you're given pi as equal to this. Okay, so let us write out the equation that was given in the question. V equals 311 sine 314.2 t. There are some basic values that we need to identify in this given equation. Okay, all right, so for 311 it represents amplitude A. Okay, for 314.2 this represents angular frequency, and from this angular frequency is equal to 2 pi, which represents radian, times frequency. Okay, so if we now make F the subject of the formula, that is, we have F equals angular frequency divided by 2 pi. Okay, alright, so now we can substitute the value for the angular frequency given here in the equation. We have 314.2 to be divided by 2 times the pi given in the question, 3.142. Okay, let us quickly use our calculator to get this. Sorry, let me bring that out. So we have 314.2 to be divided by 2 times this, we're going to have 6.284. Good. So this is going to give us 50 hertz. Okay, good. So the answer option A is the right answer. Thank you for watching. See you in the next video. Question 8, JAMB Physics 2018, which goes thus. In a purely inductive circuit, the current. First, let us take a look at pure inductive circuit. The circuit which contains only inductance, that is L, and not any other quantities like resistance and capacitance in the circuit, is what is called pure inductive circuit. Let us take a look at what this circuit look like in the diagram. So I'm going to make a quick diagram of the pure inductive circuit. So this is what the pure inductive circuit looks like. And in this type of circuit, the current lags behind the voltage by an angle of 90 degrees. Okay, so let's take a look at the options. In a purely inductive circuit, the current A lags behind the voltage in phase by 90 degrees exactly. So the answer option A is the right answer. Thank you for watching. See you in the next video. Question 9, JAMB Physics 2018, which goes thus. One of the features of the fission process is that, first let us take a look at the meaning of fission before we go into the given option. So in nuclear physics or chemistry, nuclear fission is a nuclear reaction or radioactive decay process in which the nucleus of an atom splits into smaller or lighter nuclei. Okay, that is, let me write that, nuclei. Alright, so now that we know what fission is, let us go to see what the options have to say. Option A says its products are not radioactive. The fission fragments are highly unstable because of the abnormally large number of neutrons compared with protons. Consequently, they undergo successive radioactive decay. So this answer option is not correct. Okay, answer option B, it leads to chain reaction. If one fission, I'm just using F, reaction produces two neutrons, these two neutrons can cause two additional neutrons. And if these two neutrons releases, we have four other neutrons. Okay, and so on, leading to what is called nuclear chain reaction. Okay, so this option is a feature of the fission process. Okay, let's take a look at option C, which says neutrons are not released. As we said earlier, one fusion reaction produces two neutrons. So neutrons is one of the products or the fragment of fission. So this answer option is incorrect. Alright, let's take a look at option D. The sum of the masses of the reactants equal the sum of the masses of the product. When nucleus of a radioisotope undergoes fission in a nuclear reaction, it loses a tiny amount of masses which is converted or released as energy. So this statement cannot be true. So the answer option B is the right answer. Thank you for watching. See you in the next video. This is question 10, JAMB Physics 2018, which goes thus. The graphite rods surrounding the uranium foil rods in the nuclear reactor are used to. Let's go through the options and so we can use that to answer the question. Okay, good. So a reactor grade graphite must be free of neutron absorbing materials. So graphite does not absorb neutrons, and also graphite is not used to control the reaction. So there is no way it will halt the nuclear process, though this answer option is wrong. So let's say the second answer option, create the neutrons and hence start up the nuclear process. Graphite doesn't create the neutron, instead it is the uranium foil rods that creates the neutron by fissioning the uranium atoms. Okay, so it doesn't create the neutrons, neither does it start up the nuclear reaction. So this answer option is wrong. Alright, so answer option C, slow down the neutrons and hence slow the nuclear process. Yes, graphite are used in certain types of reactors to slow neutrons emitted by fissioning uranium atoms so that they are moving at 1 kilometer to 2 kilometer per second. So graphite slow down the neutrons and hence slow the nuclear process. So this is correct. Okay, so let's take a look at the last option, which says speed up the neutrons and hence speed up the nuclear process. This is absolutely the opposite of answer option C, so it is incorrect. So the answer option C is the right answer. Thank you for watching. See you in the next video. Bye bye.